Hello guys, for this question I'm going to be solving all paths from source to target, and specifically the question here asks us to find all the possible paths from node 0 here until the last node n-1, which is 3 in this case. So given the input, which is a 2D array, and each array corresponds to the edges for each vertex, so this is for vertex 0 all the edges, for vertex 1, for vertex 2, for vertex 3, how can we solve this to find the possible path? Well, we could use a depth first search approach, but we need to first represent the graph in a data structure, and we're going to use a dictionary, which you will find is going to be very common in most of the graph questions, where the key is the vertex and the value is the list of edges for this specific vertex. So for this example, it's going to look like so. And for 2, it's going to be 3. So we can use the depth first function here to go through each of these paths in the dictionary and use another data structure to remember the paths while we recursively call the depth first function. And the other data structure that we could use here is a stack. And essentially at a high level, it will look like we call the depth first search on 0 and we append 0 to the stack. Then we go through each of the possible nodes for 0, which is starting at 1. Then we call the depth first search function at 1, which means we're going to be looking at this at the next call. But first we append 1 to the stack. Then once we're looking at 1, we call depth first search on 3, then append 3 to the stack. And since 3 is the very end, we've completed this depth first approach and we can append this to our result array. Also pop 3 from the array. So now our result array is going to contain just the first one, 0, 1, 3. And once we pop 3, we go back here to the first array, and we notice that there's no other neighbors, so we can safely pop 1 from the array, the current stack, that we have. And now once we go back here, we're looking at the second vertex now. So now we push 2 to the stack that we're currently on and recursively call depth first search on 2. And then once we go here, we do the same thing. We call it on 3 while pushing 3 to the stack. And then once we reach the 3, we notice we're at the end, and that means we can append this to the results array that we're going to return. And now the second path that we found is 0, 2, 3. So once we finish doing that, we can simply return this array with the answer that we're looking for. So what this looks like in the code is we first begin by building out the graph, as usual using the dictionary where the key is the vertex and the value is the list of the edges. And we need to return an array, so I'll call it like so. While calling the DFS function here, passing in the current start node, which is going to be 0 for this question. And we want to do a check in this function later on that we've reached the end node, which in this case is going to be the last element in the graph. And that should be it. Now onto the actual function. We have the current, we have the end, and we have a stack, which is an empty stack at the beginning. So initially we're going to be pushing into the stack the current node that we're on. And later on, we want to pop it from the stack. And now in the middle, this is where we recursively go through each edge and call DFS on it, passing the neighbor as the current, the end is going to stay the same, and the stack that we're using. And actually in this case, once we're here, we want to do another check actually right here before we go through each neighbor. And that check is simply that we realize that we're at the end. So the current and the end is the same. That means like we've reached to the node 3 in this case. So once we've reached to node 3, we know that we can return true. And if we're here, we know we can return false. And that just means, like, for example, if we have a path that's just like 0 to 1 and it doesn't go to 3, that can tell us that, okay, there is no path from 0 to 1 that can take us to the last node, so we can just return false. And where we do the recursive call, we can check for this return value. And whenever it's true, we know that we're on a correct path. We can append this to the resulting array that we're returning and also pop it from the path. And that should be it to solve this question. I accept this error that I'm getting. Oops, and I mixed this up, but while calling the copy method here, that should be it. Solve this question. Hope that makes sense, and thanks for watching.